Hello students, we're going to do our first video lesson on it's section 7.4 hypothesis testing for proportions. So one of the good things is that it's similar to the lesson that we did before, testing for means. Okay, so just to review for this one, since it's on proportions, P is the proportion for the population. So the population is everyone that you want information from, and then P hat is the sample. The proportion for the sample, which would be the small amount that you get from the population to do your study on. So that's the difference between P and P hat. And then just like when we did the confidence intervals for proportions, we have to check the conditions. In this case, it's going to be N times P and N times Q are both 5 or greater. And it has to be both, not just one. So if one of them is not greater than 5, then we can't proceed with the problem. If they're both greater than 5, then we can continue, and we're going to use this formula, which is P hat minus P divided by the square root of P times Q over N. And then just a reminder, P is the population proportion, and Q is just 1 minus P. So let's say, for example, P is 0.25, then Q would be 1 minus 0.25, which is 0.75. Okay, so let's look at an example. This one's from your book. It's going to be on page 408 if you want to follow it. So I'll show it to you. It says that a study claims that less than 20% of people have wireless internet at home. Okay, so because it's out of everyone in the US, that's going to be P. 20% of internet users in the whole US. You get a sample of 100, so that's going to be N. And out of your sample, 15% said that they don't have a wireless network. Sorry, they say that they do have a wireless network. So because this 15% comes from the sample, that's going to be P hat. And then we're going to use a significance level of 10%. So do we have enough evidence to support the claim that the researcher is making? So just like before, you first want to write down all the important information. So P hat is 0.15, P is 0.20, the sample size N is 100, and we're going to use a significance level of 0.01. Okay, so if P is 0.20, Q would be 1 minus 0.20, and that would be 0.80. Okay, so step 1 is check the conditions. Okay, so we're going to check that N times P and N times Q are both 5 or greater. So that would be 100 times 0.20 and then 100 times 0.80. Okay, so both are greater than 5. So now we're going to draw the curve. And for these problems, you can either use rejection region or p-value. You can choose. I'm just going to go move on with p-value, but if you want to use rejection region, you could. You get the same answer. So they claim that less than 20% of the users have wireless. Okay, so because it says less than, we're going to use this symbol, the less than, and that's going to be the alternative. So the null is going to be greater than or equal to, which is the opposite. And then from here, you write down the formula and you put in the information. So for P hat, we put 0.15, for P, 0.20, and then again, P is 0.20, Q is 0.8, N is 100. Okay, use Desmos. That would probably be the best one to use for this. And you get negative 1.25. Since we're using p-value, you see how this is pointing to the left? You shade negative 1.25 to the left because it's a left tail test. Then you go to your Z table and you look up negative 1.25. And that gives you 0.1056. And then from here, remember, you compare the p-value to alpha. If the p-value is lower than alpha, you reject the null. And if it's higher, you fail to reject. So 0.1056 is higher than 0.01. So because it's higher, you fail to reject. And then your conclusion would be, we don't have enough evidence to reject the null. So if you cannot reject the null, then you conclude that. So we're going to conclude that 20% or more of people have Wi-Fi, or you can say not less than 20% of people have Wi-Fi, whichever one. Okay, so in class, I would usually have you guys do a problem on your own, and you can pause the video, and then you can do example 2 on your own to see if you get the right answer. Okay, example 2 is on page 409. Okay, so go ahead and pause the video, do example 2, and then you can come back and check if you got the right answer. Okay, so this example, okay, assuming you did the problem and you want to check if you got the answer, says that 45% of people in the US agree with making cigarettes illegal within the next 5 to 10 years. And you want to test the claim using 200 people. Out of the 200, so that's going to be your N, 200, 49% support making them illegal. Okay, so because that comes from the sample, that's P hat. That's out of everyone, that would be the population, that's going to be P. So you want to write down all the important information. So P is 0.45, N is 200, and P hat is 0.49. And it says to use a significance level of 0.05. Okay, so because it says 45%, it's going to be equals. So your null would be P equals 45%. So that means there's no difference between what the study found and what the claim is. Okay, it's 45%. And this would be there is a difference. But before we do anything, we always have to check the conditions first. So N times P and N times Q. Here's N and then your P. Just a reminder, Q is 1 minus P. So if P is 0.45, 1 minus 0.45 is 0.55. So that's how we got Q. So both of them are greater than 5. So now I can draw the curve. And again, we can use p-value or rejection region, so I'm just going to do it with p-value. Okay, so this is your formula. So p hat is 0.49, p is 0.45. Then you substitute p, q, and n in the bottom. Okay, so what you want to do is you want to put this in decimals in a calculator, such as decimals. So when you do that, you get z equals 1.14. Okay, so that's what I get for z. Now this problem is different from example 1 because it's a two-tailed test. So if you remember, when you have a two-tailed test, you have to shade on both sides. Okay, so I'm going to shade 1.14. It's here. And then on the negative side, negative 1.14. And I'm going to shade on both sides. And same thing with the p-value. So if I look up 1.14, it's going to be this area here. So go to your table, look up 1.14. Or it's easier if you look up the one on the left side. So look up negative 1.14, and you get 0.1271. So because this is a two-tailed test, you want to multiply by 2. And when you do that, you get 0.2542. That's your p-value. The p-value is what's shaded in red. So I multiplied by 2 because it's a two-tailed test based on the not equals. And then I compare that to your significance level, which in this case is 0.05. And you ask yourself, is the p-value higher or lower than the significance level? So 0.25 is higher. And when it's higher, you fail to reject the null. Okay, if you want to write the sentence, then when you fail to reject, you say, there's not enough evidence to reject the null. So if we can reject the null, we conclude that there is a difference in the proportion of people that favor the ban. Okay, so that would be all.